Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is binary search tree to greater sum tree. Okay, so you will be given the root of a binary search tree, and first of all, those of you who do not know what a binary search tree is, a binary search tree is a tree in which let's open the board first. Okay, so in a BST, what happens is, let's say these are three nodes in BST: A, then B, and then C. So in every subtree, or in the entire tree also, what will happen is this whole section will be less than the middle one, or the root. So the left subtree will be, all the values in the left subtree will be less than the middle or the root, and all the values in the right subtree will be greater than the root. Okay, so if this is the root, this is the left subtree, and this is the right subtree. Okay, so if you do a in order traversal, those of you who do not know what a in order traversal is, it is basically left value, then comes the root value, then comes the right value. So this is in order. So if you this kind of traversal of binary search tree, so it will result into uh, ascending order. So it will be something like this. Okay, so as mentioned in the problem statement, okay, it is mentioned somewhat below that all the values in the tree are unique. So if all the values are unique, there is no chance of equality. So this condition will hold true. Okay, so this is what a binary search tree is in nutshell. If you are still interested in finding out more about uh, BST, so I will try to find an article, and the link will be provided in the description for that article, so you can definitely check that out. So now proceeding further in the problem statement, you have to convert it into a greater tree such that every key of the original BST, or the binary search tree, or the every node in the original binary search tree is changed to the original key plus the sum of all the keys, or all the nodes greater than the original key, or you can say the node. Okay, so what it is saying is, so if you take this binary search tree as your example, okay, just a second. Yeah, let's continue. So we were taking it to the board. So let's take a fresh slide. Yeah. So if we are at this part, if we are considering this particular key, which is 1, so what will be its new value? First of all, you might want to see the order of things here. So the order of things will be 0, 1, 2, 3, 4, 5, 6, 7, 8. So it is nothing. You can consider it something like this. Imagine you are putting force here. So when you will be putting force, these nodes will keep going down. Okay, these nodes will keep going down. So here 0, 1, 2, 3, 5. Then since this line will be contributing to 4, then 5, then 6, then 7, and then finally 8. As you can see, it comes out to be ascending order. So this is what I have written here. It is the same thing. So what will be added to 1? So all these value will be added to 1. Okay, sum of all these values. So 2 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, 21 plus 7, 28, 28 plus 8, 36. So all in all, the new value will be becoming 36. Okay, I somehow did a mistake, or the value will be 36. So it will be 1 plus 35 something, so it will turn out to be 36. Okay, so it was just addition mistake maybe, but I hope you understand what is going on here. Okay, so for example, if you take a smaller example, if you take this much only, then you will be able to see clearly. So what is greater than 7? Only 8. And what is current value of 7? It is 7, so 7 plus 8, it will be 15. Is it? It's as simple as that. Okay, for example, all the values greater than 6 sum up to 15, and 6 plus 15 happens to be 21. Okay, so it is working out like this. And if you take this example also, 21 plus 5 is equal to 26. So I hope you are able to understand. Okay, so this is what we have to do. Now from the procedure that we just did, we somehow went to the very rightmost value and started from there, and things become quite easy after that. Okay, so this is the intuition to solve this particular problem. So we will go to the rightmost value in the sorted order, rightmost value in sorted order, and we will keep a global variable. Let's call this current sum. So you will be visiting nodes something like this in this fashion recursively. First of all, you will be visiting the right node of the current subtree. Okay, then you will be visiting the root node of the current subtree. Okay, then you will be visiting the left node of the current subtree. Okay, so what will happen is, first of all, you will go to the right subtree, okay, right node of the current subtree. So you will do this thing recursively, but let's say you are here, okay, at this particular thing. So for 8, there is neither left node, neither right node. So after visiting the right node, you will visit 8. Okay, 8 is being visited. So initially your current sum value will be 0. So here, since your current sum value was 0, so 8 plus 0 will be 8 only. Then you will visit the left subtree. So there is nothing in the left subtree, so you will return anyway. So now what will happen is, during this visiting of 8, you will change the current sum also. So you will change it to the value of 8 before changing, okay, before updation. So it will be now 8. So now moving further, so you will then go here. So since 8 was the right node of the 7 subtree having root as 7, so 7 plus 8, 15. Before changing 7 to 15, you will update your current sum to 15 by adding 7. Then the value of 7 is changed. Then you will go to the left. So there is nothing in the left, so we are just fine. So we will again go like this. Okay, now 15 plus 6 21. Before changing 6 to 21, you will update 15 plus 6 to 21. Okay, and then you will go to the left. Now fortunately there is some left value, so it is 5. So first of all you will go to the right, nothing in the right. Then you will come to the node itself. So before changing the node's value, you will update the current sum, which is 26 now. Okay, and you will change the node's value to previous value of the current sum plus node's initial value. So it will be 26. Okay, so now proceeding further, now you will come here. So what's the current value of sum? 26. Okay, now before changing the value of 4, you will change the value of the current sum, which happens to be 30. Then you will change the value of 4 to be 30. Then you will come to the left subtree, and this thing will continue recursively, keep going on, keep going on, keep going on. Okay, so essentially this is the main formula, or you can say observation, that is to be made. The way you will be traversing, first of all the right subtree, right node of the current subtree, then the root node of the current subtree, and the left node of the current subtree. So that is all. And the clever use of this current sum global variable. Okay, so now let's have a quick look at the implementation. Things will be more clear in the implementation. So this is the implementation. It's quite short. So let's take it to the board. Okay, this is the implementation. So you will be having a function bst to gst helper. So this is the function that we will be using to apply that formula: right, root, then left. Okay, so if the value of the current root is null, so you will anyways return. If it is not so, then you will first go to the right subtree. Okay, now you will do some updation for the root. So first of all you will store root's value somewhere, then you will update the root's value to the current sum plus original root's value, as you know mentioned in the problem statement. And after that you will update the current sum to the previous root value by adding previous root value to it. Okay, which was stored here. So this is that part. Then after that you will be recursively visiting your left subtree. Okay, so the formula is applied, and at last you will be having the modified PST converted into GST, and you will return the root. So this is the whole problem, uh, problem solution, you can say. And time complexity wise, it is order of n, where n is the number of the nodes. Why order of n? Because each node is being visited only once here. So space complexity wise, it will be depth of BST, order of depth of BST. Okay, this will be used for recursion stack. Okay, so how much deep your BST is, it totally depends upon that. So let's say the BST is something like this, although it's just a hypothetical thing. 2 3, let's say it's skewed to right. Okay, so in that case your this thing will be stored in your recursion stack, this whole thing, when you will be visiting for. Okay, so depth of BST. So these are the complexities. If you are still, and this is the approach, if you are still having any kind of doubts or any queries in general, then please feel free to ask them in the comment section. I hope this solution walkthrough added some value to your journey of honing your DSA skills. I will see you in the next video. Till then, keep practicing and keep solving problems. Thank you for watching.